All right, so this is part 3 of a video in which we're deriving the C5h character table. So where we got last time is we knew there was ones across the board for the first irreducible representation. That's true for every character table. And then we had this z function that we tested. We got five ones and 5 negative ones. And then we figured out that x and y transform together when we tested x, and we have some, cosines in our characters. So at this point, we still have quite a number of irreducible representations to puzzle out, and so it's best to just keep testing different functions, and so we can test quadratic functions. So one quadratic function we can test, doesn't really matter where you start here. We can test xy. So let's try to test xy. That's a quadratic function. That's the function that describes one of the 5 d orbitals. And so, of course, if we do an identity on xy, we go to xy. If we do a C5 on xy, well, we have to think about how x transforms and how y transforms. So we do cosine 2 pi over 5, cosine 2 pi over 5, minus sine 2 pi over 5, and sine 2 pi over 5. That's how x and y transforms, right? And so let's just write that out here. So xy, so x goes to cosine 2 pi over 5x minus sine 2 pi over 5y. And then y goes to sine 2 pi over 5x plus cosine 2 pi over 5y. And so we have two expressions like this, and so what do we have to do? We have to FOIL them out. So we're going to get cosine squared 2 pi over 5xy minus sine squared 2 pi over 5, that's timesing these terms, xy. And then the same terms, so x times x, that term, which gives us an x squared. It's going to be cosine 2 pi over 5 sine 2 5 x squared. And then we have a minus same term, but with a y squared. 2 pi over 5 sine 2 pi over 5 y squared. And all of that is going to be equal to, well, what can we do here? We can factor out some terms. So we can factor out a cosine 2 pi over 5 sine 2 pi over 5 x squared minus y squared. And then we can factor out an xy. And that term there is going to be cosine squared 2 pi over 5 minus sine squared 2 pi over 5. Well, there's this relationship in trigonometry you may or may not remember, which is cosine squared x minus sine squared x equals cosine 2x. So let's take advantage of that. And so instead of factoring out a cosine squared x minus a sine squared x, we're going to factor out a cosine 2x, which is going to be 4 pi over 5. So then we just get plus cosine 4 pi over 5xy. And so what we can see here is that xy actually transforms as a linear combination of x, y, and x squared minus y squared. Another way of saying that is you can't describe how x, y transforms in this space without also taking into account how x squared minus y squared transforms. In other words, x, y, and x squared minus y squared transform together. Remember, these are both d orbital functions, right? X squared minus y squared. This is d orbital function that's rotated 45 degrees. So what that means is back up here on identity, we have to write x squared minus y squared. It goes to x squared minus y squared. And we're going to get an identity matrix that explains how x, y, and x squared minus y squared transform. And then we're going to take the character of that matrix, as we always do, which is the sum across its main diagonal. And that tells us that the chi of the identity operation is going to be equal to 2. So our first character here, again, is going to be equal to 2. And that's the dimensionality, we call it. And it describes how many functions transform together. So this is 2 functions transform together. So we have character 2. But we have to figure out now how x squared minus y squared transforms with doing a C5 operation. So we take x and square it. So I'm going to write out this first term. This was how x transformed. We're going to square that and write the 4 terms that we get from the result of squaring that. Cosine squared 2 pi over 5 x squared plus sine squared 2 pi over 5 y squared. And then we're going to have 2 of these identical terms. So we're going to put minus 2 cosine 2 pi over 5 sine 2 pi over 5 xy. And then we have to minus a y squared component. And so we have to square this. That's how y transforms. So we have to square it. I'm going to factor that out or FOIL it out. And so remembering that we always are going to have minus the signs here. So we're going to have minus sine squared 2 pi over 5 x squared minus cosine squared 2 pi over 5 y squared. And then we have, again, 2 of the similar terms, the cross terms, cosine 2 pi over 5 sine 2 pi over 5 times xy. And so if we simplify this, what are we going to get? Well, we have this negative 4 cosine. Those terms collapse together. 2 pi over 5 sine 2 pi over 5 xy. And then we have these other terms. And what we want to do here is try to factor out an x squared minus y squared. Well, how can we do that? Well, we're going to use this cosine squared x minus sine squared x equals cosine 2x relationship. Cosine squared 2 pi over 5 minus sine squared 2 pi over 5. There it is. That's the x squared component. So that's going to collapse, simplify into cosine 4 pi over 5. So plus cosine, right, 2x. So cosine 2 times our x value there. Cosine 4 pi over 5. That was for x squared. And then if we look at this y squared component, we have a positive sine squared value, and we have a negative cosine squared value. Well, that's just the negative of this. Positive sine squared and negative cosine. So we're going to get negative cosine 2x. So that's going to be our y squared component. So we actually just we can factor out just a cosine 4 pi over 5. And that's what we end up getting. And so our matrix here that describes our transformation for C5 operation, we are taking xy and x squared minus y squared, we know those transform together. And we only care about the on-diagonal components of our matrix, which are what the component that goes into itself. So xy went to cosine 4 pi xy. So the value here is cosine 4 pi over 5. And then for x squared minus y squared, again, it's cosine 4 pi over 5. That was the part that's times by x squared minus y squared. So then we can take the sum across the diagonal here to get the trace of our matrix. And we get the trace is equal to sorry, 2 cosine 4 pi over 5 plus cosine 4 pi over 5 equals 2 cosine 4 pi over 5. And that is what we can plug in for C5 with this representation. You can see it's different than before. Before we got 2 cosine 2 pi over 5. Okay, so what's going to happen when we do a C5 twice? When we do a C5 twice, all these 2 pi over 5s are going to become what? 2 times that, because we're rotating twice as much, 144 degrees instead of 72 degrees. So all these values are going to become 4 pi's over 5s, right? And when we do that and work through all this, we're going to get these cosine 2x's, and those are going to become not 4 pi over 5, but they're going to become 8 pi over 5, right? And so if you think about this generically, if we just put a term theta in for all of here, we could write this very, very generically, where instead of having cosine 4 pi over 5, we have instead cosine of 2 theta coming from this cosine 2x, where theta is the amount that we rotated by. In this case, we're doing a C5, so we rotated by 2 pi over 5. And so we got a value of cosine of 2 cosine 2 pi over 5. But if we generalize this to not just be C5, but a C5 n times, right? Then we could change this to being 2 cosine 2 theta. So now we can just go through and think about, all right, if we have theta equals to 4 pi over 5, right? We're doing a different, twice as much rotation for the C5-2. Then our character of C5-2 is going to be equal to 2 cosine 8 pi over 5. And 2 cosine 8 pi over 5, cosine 8 pi over 5 is actually equal to 2 cosine 2 pi over 5. If you do your unit circle analysis, just a trigonometric relationship here. And so up here, we can put 2 cosine 2 pi over 5. And then we keep going along. So if theta equals 3 times what we started with, 2 pi over 5, so 6 pi over 5, that describes a C5 3 times. And that equals, the character equals 2 cosine 2 theta. So we're at 2 cosine 12 pi over 5. And so we have to think about what cosine 12 pi over 5 is. But if you think about how many degrees that is, that ends up being equal to 432 degrees. Basically 12 times 180 divided by 5. And that's the same, 432 degrees rotation is the same as doing a 72-degree rotation. And so that's the same as 2 pi over 5, right? So cosine 12 pi over 5 ends up equaling cosine 2 pi over 5. So we can put that down here. And then our last one, we have a C5 4 times. And so our theta actually equals to 8 pi over 5. And so our character for C5 4 times is 2 cosine 16 pi over 5. That ends up equaling cosine 16 over pi over 5 is the same thing as cosine 4 pi over 5. Because we went basically 4 pi over 5 more from something that was equivalent to 2 pi over 5, so that went to something like 6 pi over 5, which is anyway ends up being equivalent to 2 cosine 4 pi over 5. So that's our character. Okay, so now we get to sigma h. Sigma h is a fairly easy one to do. We know that x went to x, where sigma h was in the xy plane. And so if we have an x vector or y vector, those are both in the xy plane. So we're going to have the identity matrix describing this transformation. And so that is going to give us a value of 2. Right? Take the trace across that matrix. I think you guys can see that at this point. 1 plus 1 is 2. And now what about the S5s and S5.3s and S5.7 and S5.9s, the improper rotations? Remember, those are just C5s followed by sigma h. Well, sigma h didn't do anything. So those are just going to be copied across the board. They're the same characters as what we derived before. So that's going to be 2 cosine. We had a 4 pi over 5 for C5. Remember, an S5 is a C5 followed by sigma h, but sigma h doesn't do anything. S5 3 times, but think about this for a second, that's the same as doing a C5 3 times followed by sigma h. So we're going to be the same because sigma h doesn't do anything with x times y, the same as the character for C5 3, which is 2 cosine 2 pi over 5. And then S5 7 times, S5. Well, that's the same as doing a C5 7 times followed by sigma h 7 times, which is the same as sigma h. Sigma h doesn't do anything, so it's going to be the same in this case with x and y. So same as a C5 7 times. Well, C5 7 times is the same thing as doing an identity, C5 5 times, right? Because that spins all the way around. So we only have 2 C5s less, so it's really the same as a C5 2. So it's 2 cosine 2 pi over 5. And you can see these patterns. You know, anytime you had a 4 pi over 5 up here, you get a 2 pi over 5 down here. And then this one ends up S5.9 for similar reasons, ends up being the same as a C5.4. So you're going to get, and if that matches the patterns as well, 2 cosine 4 pi over 5. So we've derived the next symmetry element, or next function. We figured out how xy and x squared minus y transform together. The next thing we're going to have to do is test even more functions, because we have to keep deriving these. We still have quite a few functions to derive. So we'll work on that in the next video.